Hi everyone, this is Professor Majumdar and you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Let's get started.
Hello viewers, today I'm going to show finite element analysis of a plate with a hole. In this case, our task will be to find out stress concentration factor. Let us see the statement of the problem. Obtain stress concentration factor for a plate with a hole under tension, and modulus of elasticity of that material is equal to 200 gigapascal. That means 2 into 10 to the 11 Newton per meter square, and Poisson's ratio is 0.3. Plate thickness is provided as 20 millimeter, and we need to provide a pressure of 1 megapascal or 1 into 10 to the 6 Newton per meter square at the right hand side. Right? So without wasting time, let us start the model. We can do one thing, that while modeling, as it is a symmetric object, we can make the object as 1/4 and we can model it. So our compression time will be smaller. So we consider the 1/4 of the model, right? Total length of the model is equal to 200 millimeter and this breadth equal to 100 millimeter. So this will be half of that one. We'll consider length of the model equal to 100 millimeter and the height will be equal to 50 millimeter. Okay. So without wasting time, let us start our analysis using ANSYS mechanical epidel. Okay. Right. First of all, we need to create a directory and everything should be saved in that directory. Next to that, we need to change the title of this one, right? So it will be started from file, change title, and we are keeping the name of the title as AVA15. To see the title, plot replot. It will show the title at the lower left corner, right? In ANSYS mechanical epidel, we need to start from top to bottom. First of all, we need to start from preferences, and it will show what type of analysis it is. It is a static structural analysis. Okay. Next to that, we need to define element properties. So preprocessor, element type, add, edit, delete. We need to add it. In this case, we are considering solid with quad 4 node 182. Okay. From options, we can select element behavior as plane stress with thickness. Okay. And we can provide thickness from real constants. Add, edit, delete. Add. Okay. We know that the plate was having thickness of 20 millimeter, so it will be 0.02 meter. So thickness we are providing as 0.02 meter. Okay. Close it. Next to that, we need to provide material properties, material models, structural, linear, elastic, and isotropic. Isotropic means material property remains same in all directions, right? And modulus of elasticity of that material is 2 into 10 to the 11 Newton per meter square. That is 2E11, and Poisson's ratio is 0.3. Okay, let us close this one. Next to that, we need to start modeling, create areas, and we need to create rectangles by 2 corners. We can provide the center at origin. So x coordinate and y coordinate will be at 0, 0. Width will be 100 millimeter, that is 0.1 meter, and height is 50 millimeter, that is 0.05 meter. Apply. Now at the center of this one, we need to provide a circle of radius 20 millimeter or diameter 40 millimeter, right? So circle, solid circle, it will be started from origin. So x and y, it will be 0, 0, and radius will be 20 millimeters, that is 0.02 meter. Okay, done. Unwanted areas to be subtracted, and that will come from operate, booleans, subtract areas. For subtraction of areas, first of all, we need to select all areas, then we need to select the area which need to be subtracted. So first of all, we'll select all areas, right? Select the left hand side areas, then the rectangle one. Okay, we selected all areas. Now the area which one will be selected, that one will be subtracted. So select the circular part. Okay, done. So the circular portion is subtracted from the main area, right? Our model is ready. Next to that, we need to start our meshing. So meshing, size controls, manual size, areas, all areas. Let us provide element edge length equal to 1 millimeter, that is 0.001 meter. Apply. Now we need to mesh it. Mesh areas, free, pick all. Meshing is done. It is quite good enough. Now we can apply our boundary conditions, right? So loads, analysis type, it is a new analysis and it is definitely a static structural analysis. Okay, so define loads, apply structural displacement, and as it is a symmetric object, so we can provide symmetric boundary conditions. Symmetric boundary conditions on lines. It is symmetric along this vertical line and also this horizontal line. Selected. Okay. Now we need to apply a pressure of 1 megapascal at the right hand side. So pressure on lines, let us select the exact location selected. Okay, and pressure is in this case equal to 1 megapascal, that is 1 E6 Newton per meter square, and as it is away from the center, so it will be minus 1 E6. Pressure is applied. Now we need to solve it. So solution, solve, current LS. If everything is right, it will show solution is done. Okay, it is showing solution is done, so everything is perfect. We can see our results. Let us close it. We need to see our results from general post processing, right? Before that, we need to see the whole model. So what can we do is plot controls, style, and symmetric expansion, periodic and cyclic symmetry. We can select 1/4 dihedral symmetric. Okay, so this is the whole model. First of all, we'll read results from last set. Now we can see our results from listing. It will be in the form of data. So list results, nodal solution, and when you see stress, actually stress concentration factor, it is a ratio of first principal stress and one with stress, right? Let us check first principal stress, how much it is. It is showing that maximum principal stress is occurring at node number 232. It is 0.37199 into 10 to the 7 Newton per meter square, right? Next to that, we want to see maximum 1 meter stress, and the ratio of these two will provide the stress concentration factor, right? And again, nodal solution, and we want to see maximum 1 meter stress. So let's check it from here. 1 meter stress. Okay, it is showing that maximum 1 meter stress is also occurring at node number 232. It is 0.37199 into 10 to the 7 Newton per meter square. So the ratio of these two will provide the stress concentration factor. It is equal to 1, right? Let us close this. Next to that, we want to see our results in the form of plotting. So plot results. First of all, we'll see deform results, deform shape, deform plus undeformed. We want to see the results by the application of pressure. Okay, so this one is showing the deform plus undeformed, both the objects. It is better to see the results in the form of 3D objects. So plot controls, style, size and shape, and display of elements should be on. Okay, done. Now to see the results in a better way, let us see the isometric view. So this is the object. Actually it is showing deformed plus undeformed results. Okay, next to that, we want to see stresses also and displacement. Both the things can be seen. So contour plot, nodal solution. Want to see displacement along x directions. So DOF solution, x component of displacement. Okay, so this is showing displacement along x component or x direction. Maximum displacement is occurring at the starting and finishing point at this location and at this location. It is 0.629 into 10 to the power minus 6 meter occurring at this location, and minimum displacement is occurring along the vertical line to the central hole, right? Okay, next to that, we want to see stresses also, right? So nodal solution, stress, and we want to see first principal stress. You can see maximum stress is occurring at this location. Let us see it from front view. So you can see maximum stress is occurring at this location, right? Indicated by red color. And let us see maximum bond measure stress also. So stress, and we see bond measure stress. It is also showing the same results. Maximum bond measure stress is also occurring at this location. Now we'll do one thing. We want to see the location of maximum bond measure stress. That will be shown through the listing results. And we want to see the actual node numbers, at which node maximum stress is occurring, that to be checked, right? So plot controls, numbering, and we can select node numbers to be on. Okay, plot nodes. It is showing actual numbers of nodes in this analysis, and we know that maximum stress is occurring at node number 232. We need to identify that location. So what we'll do is plot controls, style, size and shape, and display of element we will make it off. Then it will be easier to understand. plot, replot. Okay, now we need to find out the location of maximum stress. So what we'll do is plot contours, pan, zoom, rotate, and you can select box zoom. This is actually node number 232. So at this location, maximum stress is occurring. Maximum one phase stress and maximum principal stress is occurring at this node number 232. Okay, so this is the actual location of maximum stress. Okay, so this is all about our today's analysis. In this analysis, we have shown the stress concentration factor for a plate with a central hole, and excluding that one also we have find out maximum principal stress and maximum one phase stress and also displacement along x direction. Okay, so thank you so much for watching this video. Thank you again. Bye. If you like this video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.